They get in a fight in the hallway.
I will record it and show her for evidence.
Video's running, we got a lot to do, we're gonna get ourselves organized.
You got 1 minute.
Come on. Okay,
I'm going to. Do you see how she?
so on the last time we were together, we talked about the regular cosine and sine function and how they can be changed in terms of period and amplitude, right? Amplitude refers to the verticalness, period refers to the horizontal, right? So, I'm taking a look at problem 4A, and I'm going to graph this. Okay, so I need you to pay real close attention, because we need to look at problem 5 today. And we don't have a lot of time, so pay real close attention. I went ahead and just to jog my memory, this is the regular old cosine curve. And that's the regular old sine curve. Now, there have been a couple modifications to this picture. First of all, for the first time, I'm pretty sure, yeah, we have a plus sign in there. Who remembers what adding and subtracting to x does to your picture? Sam? Brent?
Left and right.
Left and right, it's gonna move it left and right. So, we are today not only going to change this and change this, but we're going to change where it's positioned. Okay? So here's what we do first. If that x has a coefficient inside the parentheses, I need you to pull it out. So we're going to factor out of 4, which would mean x plus what? Pi over 2, right? Factoring is division, so I'm going to divide by 4, so that gives me pi over 2. Is everybody okay with that? Now, let's talk about where this picture has been shifted to. That's a plus. What does that mean? Which way do we go if it's a plus?
Left.
We go left, and we go left that amount. So what that means is, here, I'm going to label this negative pi over 2. What used to happen at 0 now happens here. So I'm going to go ahead and draw in my cosine curve. Now, I'm not exactly sure. I'm going to have to figure out some stuff here, but I'm going to go ahead and sketch that in. I may have to erase it and redo it. I need to figure out all of these hash marks, each quadrant. There's quadrant 1, 2, 3, 4, adjusted quadrant. I need to figure out how high it is. Well, that's easy. How high up does it go? 2, and down to -2.
We don't know.
Now, what is the normal period, the normal length of a cosine curve? Where does it normally end?
2 pi.
2 pi. 1 revolution around the circle, right? 2 pi. This guy right here divides that. So now the period is 2 pi divided by 4. So the entire picture happens in pi over 2. Would you agree with that? Well, when I said I was going to have to change my picture, I'm going to have to change my picture. Because now, we start at negative pi over 2. That's what the phase shift, oh, I haven't used that word yet, but that's what the shift is, right? But now where does it have to end?
0.
At 0. It has to end here. Because the whole length of one period is pi over 2, and since it's starting at negative pi over 2, the whole thing is going to get accomplished in that far. Does that make sense to everybody? So first thing I did, well, first I factored out this number. You always need to do that. If it's already factored out, great. If it's not, you need to factor it out. Then this tells you how your picture has been shifted. That is called the phase shift. So for this problem, the phase shift is negative pi over 2. Your picture has been backed up pi over 2. Then we figured out the period. The normal period is 2 pi. We find horizontal changes by taking the normal and dividing by this coefficient. This coefficient divides the horizontal. So that's how we said, okay, the whole curve, that whole shape, happens in pi over 2 units. Since I started at negative pi over 2, that means I'm ending at pi over 2. Now, could I draw another one and another one? Sure, but you only need to draw one. Now, you need to find these, oh, you already told me these were 2's, right? Now, I need to find all the rest of these labels. Well, don't make this hard. If this is negative 1/2, and that's 0, what's the one right in the middle? Negative 1/4. And if that's negative 1/4 and that's 0, what's the one right in the middle? Negative 1/8. And if that's negative 1/8 and negative 2/8, then this one's going to be negative 3/8 because that one is negative 4/8. Remember, these spaces here represent the quadrants. The 4 quadrants as you go around the circle, they're evenly spaced. We might stretch them and smash them or whatever, but they're evenly spaced always. Done. Okay? Let's step over here and look at this one now. This is a sine curve. Once again, we've got a coefficient in there, so let's divide that out. It just comes right outside the parentheses. Okay? So we can bring it right outside the parentheses, factor it out. So what's this going to be? Now remember, factoring is division. If I said factor this, you'd say this automatically, right? Where did that 4 come from? I mean, where did that 2 come from? It's 4 divided by 2. So if I'm factoring out a 1/2, I'm dividing by 1/2, which is timesing by 2. So this is 2 pi over 7. Notice, if you distribute it back, what's 1/2 times 2/7? Isn't it 1/7? All right, so now, where I got, I've got a sine curve that has been shifted to 2 pi over 7. So it normally would have started at the origin. Well, now it is starting here. You with me? Furthermore, it normally would be going hill and then valley. But look at that. What does that do? Makes it valley and then hill. Now, you need to label, of course, the 0. You have start and end, 0 in the middle, and then the minimum and the maximum. Those are your 4 sections you have to label. In order to do that, I really need to know the length of the curve. I need to know the period. Well, how do we find the period of a sine or a cosine? We take the normal period, which is 2 pi, and we divide it by that number. So my period is 2 pi divided by a half, which is 4 pi. So my picture doesn't look like it, but this guy has been majorly stretched, right? Okay, now, that means that from here to here, one hill, one valley, one hill, is that far. Should I put a 4 pi right here? No way. I can do that if I start at the origin. How am I gonna find that end point? Add it to 2 pi over 7. So 4 pi over 1 plus 2 pi over 7. Get a common denominator. It looks like that'll be 30 pi over 7. Now, see this point right here? That's halfway in between. Midpoint. Remember? You don't remember this, but I told you back in chapter P, when we were doing midpoint, I said you're really gonna need this when we graph our trig functions. That's the midpoint of 2 and 30. How do you find the midpoint? You average. 2 plus 30 is 32, divided by 2 is 16, pi over 7. And then we do it again. 2 plus 16 is 8, divided by 2 is 9 pi over 7. And then you can either notice that you're going from 2 to 9 to 16. So it looks like we're adding 7, so you can add 7 again. Or you can say 16 and 30 is 46, and half of 46 is 23. What's our amplitude? Positive 1/3. Right?
I'm confused on the last graph how we shifted the whole thing over. Is it because it was the negative pi over 2?
Yeah, it goes left. Goes left.
Why wouldn't the amplitude be negative 1/3?
We already talked about that. Somebody tell her, why is amplitude never negative? It's height. Height can't be negative. Okay, so I'll do either C or D. Which one? I only have time for one. Which one do you want to do? C or D? Why don't we do D? Because it has more going on. Is that all right if we do D? Okay, so let's take a look at D. It has an additional complication. What is the extra piece now that's thrown into problem D? There's a +1 on the end. Who remembers what that does? That's your vertical shift, right? So this picture has been stretched, this way, shifted, and lifted, or lowered, right? Lots happening. All right, so here we go. What's the first thing we have to do? Move the 3 out. And that will leave me with x minus pi over 3, right? 1/3 pi or pi over 3. Now, this is a sine curve, so it's going to have that shape right there. But instead of starting at the origin, which is where it's supposed to start, it's going to get shifted pi over 3 to the right. Now I'm going to hold off on that for a second, so just time out. I'm going to hold off on that for a second. I'm going to graph this first. All right, so I go over pi over 3. I'm a positive sine curve, which means I go hill and then valley. My amplitude is 2. okay so far? Now, all I need to do now is find these labels, but I can't really do that until I know what my period is. How long is this curve from start to finish? That is one hill, one valley. Well, it's supposed to be 2 pi, but that has been divided by 3. So that means a hill and a valley is 2/3 pi. Okay? So where am I ending? If that's the case, where am I ending? At pi? You think of that as 3/3. Where's my middle then? If this is 1/3 and that's 3/3, then the middle must be at 2/3. Does that make sense to everybody?
Where'd you get the 2/3?
The period is always 2 pi divided by this number. We gotta know that. We gotta know it to do the next problem. Now, what's halfway in between 1/3 and 2/3? Well, what's 1/3 plus 2/3? That's 3/3, right? Divided by 2 would make 3/6 or 1/2. What's halfway between 2/3 and 3/3? Well, 2/3 and 3/3 is 5/3, and half of that is 5/6. Bless you. Now, there is always, especially, if we're making up just random weird problems, there's always a lot of fraction work involved here. I don't care one way or the other if you reduce or not. So if you leave this as 3/6, I'm fine with that. If you leave this as 3/3, I'm fine with that. Because there's so much addition going on that you need a common denominator, and a lot of times it's just easier not to reduce. That's up to you. Now, what have I not done? Now I have to take the whole picture and move it up 1. So instead of oscillating between -2 and 2, it's now going to be oscillating between -1 and 3. So you can even imagine a new axis through there. You don't have to do that if you don't want to, but that's what's happening, right? Everything's getting lifted up 1. So now we're starting here, going up to 3, coming down to 1, finishing up right there. So the black thing is the answer to the question. Let's make a list of all of the important characteristics for this curve. Amplitude, period, frequency, phase shift. This is phase shift, sometimes called horizontal shift, and vertical shift. Here it is. Tell me anything. What do you know there in that list? What do we know? Well, we know the period's 2 pi over 3 because I wrote it down already. How do we find period? 2 pi divided by that number. And what does period mean? 1 cycle of the curve. So in the sine, 1 hill, 1 valley. But what else do we know? Amplitude is 2. Kids, picking it up and moving it, did that change the height of the hills? No, 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 that's amplitude still 2. What's the frequency? Who remembers from the other day?
3 pi over 2.
Not 3 pi over 2.
Oh,
3 over 2 pi. It is the actual reciprocal of the period. Phase shift, positive pi over 3. Didn't we move our picture pi over 3 to the right? So you can either say positive pi over 3, or you can use the word right, if that's easier for you. Right means positive. Left would mean negative. And what's my vertical shift? You can either say 1 or up 1. That's your vertical shift. All right, now we need to look at problem 5. Because we're going to do all this kind of in reverse. So here we go, problem 5. What do we know? High tide occurred at 9:36. At that time, the water was 2.7 meters deep. Low tide, and it was 2.1 meters deep. All right, so let me draw something here. My high point was 2.7, and my low point was 2.1. And the high point happened at 9:36 a.m. Okay, that's 9 hours and 36 minutes. Can we make that a decimal hour? What would that be decimally? Because I have to graph all this. It's just be easier if it's decimals. What is it? 9 point,
0.6.
what?
0.6.
9.6? How did he get that? 36 divided by 60? Okay. Low tide was at 3:48 p.m. Okay, so this was high tide. Low tide is out here. Let's change that into a decimal. What will that be decimally? 15.8. Love it. Why is it 15? Because it's PM, right? This is going 24 hours. This is PM. 3 o'clock would be back here somewhere. Very good. Okay, let's see this question. Assume that the depth of the water is a sinusoidal function. So do you kind of see it a little bit here, guys? Kind of see that? Going up, the tide going up and down. The period is half a lunar day, which is 12 hours, 24 minutes. So what is that decimally? The period is what is it? 12.20, what is that? 12.4? Okay. At what time on the 4th of July did the first low tide occur? Well, the first low tide would have been back here. Things aren't spaced very well, but can you figure out when that is? When was that first low tide?
Wouldn't it
24.
be like half of the, would it be like subtract half of the period?
From what?
You would subtract half of the period, so like 6.2 from 9.6?
Okay, I think that'll work. You can also subtract 12.4 from 15.8 because aren't these a period apart? So either way, what is that? 12.4, 3.4? So the answer to the first question is 3.4 hours, which would be 3 and 24, so 3:24 in the morning. What was the approximate depth of water? Oh, wait a second. Let's skip to C. The C we can do first. What's right in the middle of these two? Isn't 2.4 right in the middle? So if you think about that being the axis of our problem, the first time that happened, looks like it's right there. Maybe it could be over here, I'm not sure. Let's find this point and see. What would that point be? How did you get 6.2?
Just subtract the 2.4 minus, or from the 9.6. To get the middle, subtract 3.4 from 9.6. Yeah. Oh, yeah.
So 6.5?
Yeah.
Okay, how did you get that? You averaged. Isn't that gonna be right in between the bottom of the hill and the top of the valley, other way around, you know what I mean? Right in the middle. So 6.5. Remember, midpoint, Sam, is an addition, not a subtraction. Okay, so if I have one of those there, obviously I know I'm gonna have one back here somewhere. Where is it gonna be? Well, how far apart are these? 3.1. So where is the one back here going to be? At 0.3? Is my math right? So when was the first time that day that happened? 12 something, right after midnight. What did you say it was? 3.1? So that would be, or not 3.1. 0.3. And that's 3/60, so what is that? 12:18 a.m. Now, the next question, or B, that's C. B is tricky, because B asked me about 6 a.m., which would be like right here, right? And I don't know what that is. It isn't one of my special evenly spaced things. So I'm gonna need to write the equation of this curve. Now, what do you see when you look at this curve? Now, I know I got a lot of extra points running around in there. I kind of see a sine curve when I look at that. It could be either one. I think I'm gonna go ahead and think of it as a sine curve. It could be a cosine if I started here. Do you see that? So I got a sine curve. Potentially, I have numbers in 4 places. We just talked about that. What does this number have to do with? The amplitude, which is the height of the wave. All right? How high are these waves? 0.3. So that's your amplitude. Kids, it goes from 2.1 to 2.7. That's a total of 6. 6.6 divided by 2 is 0.3. It's going up 0.3 and down 0.3. That's its amplitude. What's this number have to do with anything? That's how much I lifted it up. So it lifted up 2.4. What's this number have to do with anything? Left and right. So if I'm thinking of this as a sine curve, this would be my starting point. The starting point should be at the origin. It got shifted over. All my numbers are blending here. Is that 6.5?
Yeah.
So that's going to be x minus 6.5. And then what does this number have to do with anything? me find the period. Now, they told me that the period was 12.4. How do I find period? I take 2 pi and divide it by that number. That's how you find period. It's 2 pi divided by that coefficient. So what does that coefficient equal? 2 pi over 12.4? Wait. There's your equation. Now, how are you going to answer the question? At 6 a.m., x is 6, and you're going to type that into your calculator and find it. And do the same thing for the other time. Yep.
If it's not 3, would that be 8?
Yes. Remember that 3 p.m. and you have to add 12.